It is this differentiation of the elements which constitutes their differentiation of position. An abstractive element which belongs to a punct has the simplest type of position in M. An abstractive element which belongs to a rect but not to a punct has a more complex quality of position. An abstractive element which belongs to a level and not to a rect has a still more complex quality of position. And finally, the most complex quality of position belongs to an abstractive element which belongs to a volume and not to a level. A volume, however, has not yet been defined. This definition will be given in the next lecture. Evidently, levels, rects, and puncts, in their capacity as infinite aggregates, cannot be the termini of sense awareness, nor can they be limits which are approximated to in sense awareness. Any one member of a level has a certain quality arising from its character as also belonging to a certain set of moments, but the level as a whole is a mere logical notion without any route of approximation along entities posited in sense awareness. On the other hand, an event particle is defined so as to exhibit this character of being a route of approximation marked out by entities posited in self-awareness. A definite event particle is defined in reference to a definite punct in the following manner. Let the condition sigma mean the property of covering all the abstractive elements which are members of that punct, so that an abstractive set which satisfies the condition sigma is an abstractive set which covers every abstractive element belonging to the punct. Then the definition of the event particle associated with the punct is that it is the group of all the sigma primes, where sigma has this particular meaning. It is evident that, with this meaning of sigma, every abstractive set equal to sigma prime is itself a sigma prime. Accordingly, an event particle as thus defined is an abstractive element, namely it is the group of these abstractive sets which are each equal to some given abstractive set. If we write out the definition of the event particle associated with some given punct, which we will call π, it is as follows. The event particle associated with π is the group of abstractive classes each of which has the two properties, one, that it covers every abstractive set in π, and two, that all the abstractive sets which also satisfy the former condition as to π and which it covers also cover it. An event particle has position by reason of its association with a punct, and conversely the punct gains its derived character as a route of approximation from its association with the event particle. These two characters of a point are always recurring in any treatment of the derivation of a point from the observed facts of nature, but in general there is no clear recognition of their distinction. The peculiar simplicity of an instantaneous point has a twofold origin, one connected with position, that is to say with its character as a punct, and the other connected with its character as an event particle. The simplicity of the punct arises from its indivisibility by a moment. The simplicity of an event particle arises from the indivisibility of its intrinsic character. The intrinsic character of an event particle is indivisible in the sense that every abstractive set covered by it exhibits the same intrinsic character. It follows that, though there are diverse abstractive elements covered by event particles, there is no advantage to be gained by considering them, since we gain no additional simplicity in the expression of natural properties. These two characters of simplicity enjoyed respectively by event particles and puncts define a meaning for Euclid's phrase without parts and without magnitude. It is obviously convenient to sweep away out of our thoughts all these stray abstractive sets which are covered by event particles without themselves being members of them. They give us nothing new in the way of intrinsic character. Accordingly, we can think of rects and levels as merely loci of event particles. In doing so, we are also cutting out those abstractive elements which cover sets of event particles, without those elements ever being event particles themselves. There are classes of these abstractive elements which are of great importance. I will consider them later on in this and in other lectures. Meanwhile we will ignore them. Also, I will always speak of event particles in preference to puncts, the latter being an artificial word for which I have no great affection. Parallelism among rects and levels is now explicable. Consider the instantaneous space belonging to a moment A, and let A belong to the temporal series of moments which I will call alpha. Consider any other temporal series of moments which I will call beta. The moments of beta do not intersect each other, and they intersect the moment A in a family of levels. None of these levels can intersect, and they form a family of parallel instantaneous planes in the instantaneous space of moment A. Thus the parallelism of moments in a temporal series begets the parallelism of levels in an instantaneous space, and thence, as it is easy to see, the parallelism of rects. Accordingly, the Euclidean property of space arises from the parabolic property of time. It may be that there is reason to adopt a hyperbolic theory of time and a corresponding hyperbolic theory of space. Such a theory has not been worked out, so it is not possible to judge as to the character of the evidence which could be brought forward in its favour. The theory of order in an instantaneous space is immediately derived from time order. For consider the space of a moment M. Let alpha be the name of a time system to which M does not belong. Let A1, A2, A3, etc. be moments of alpha in the order of their occurrences. Then A1, A2, A3, etc. intersect M in parallel levels 1, 1, 1, 2, 1, 3, etc. Then the relative order of the parallel levels in the space of M is the same as the relative order of the corresponding moments in the time system alpha. Any rect in M which intersects all these levels in its set of puncts thereby receives for its puncts an order of position on it. So spatial order is derivative from temporal order. Furthermore, there are alternative time systems, but there is only one definite spatial order in each instantaneous space. Accordingly, the various modes of deriving spatial order from diverse time systems must harmonize with one spatial order in each instantaneous space. In this way, also, diverse time orders are comparable. We have two great questions still on hand to be settled before our theory of space is fully adjusted. One of these is the question of the determination of the methods of measurement within the space. In other words, the congruence theory of the space. The measurement of space will be found to be closely connected with the measurement of time, with respect to which no principles have as yet been determined. Thus our congruence theory will be a theory both for space and for time. Secondly, there is the determination of the timeless space which corresponds to any particular time system with its infinite set of instantaneous spaces in its successive moments. This is the space, or rather these are the spaces, of physical science. It is very unusual to dismiss this space by saying that this is conceptual. I do not understand the virtue of these phrases. I suppose that it is meant that the space is the conception of something in nature. Accordingly, if the space of physical science is to be called conceptual, I ask, what in nature is it the conception of? For example, when we speak of a point in the timeless space of physical science, I suppose that we are speaking of something in nature. If we are not so speaking, our scientists are exercising their wits in the realms of pure fantasy, and this is palpably not the case. This demand for a definite habeas corpus act for the production of the relevant entities in nature applies, whether space be relative or absolute. On the theory of relative space